Hi, and welcome to my channel TechneMoira. Today's episode is all about repairing a cooking top and an ultrasonic cleaner. So grab your favorite drink or snack, sit back and enjoy the show. Okay, so as I said in the introduction, this cooking top is broken, and more specifically the cooking plate you see on the bottom right down there is not heating. Well, I would say it's still heating a little bit, but not too much. It takes really a very long time to heat up to cooking temperature. So it's spent. It's not quite broken, but really spent, and therefore I need to replace it. And I bought, in fact, a new cooking top for it. Let me show you. So this is a new cooking top that I bought to replace the broken one you see over there. Now, these cooking top elements are rather generic, okay? So if you go look around to buy a new element like this, usually it'll be of the Ego brand, okay? So EGO. Let me show you in a close-up. Alright, so this is a 1 kilowatt Ego cooking plate, right? Remember, I'm located in Europe, and here we use 220 or 230 volts AC, 50 Hertz, okay? So either way, these cooking top elements are rather standard, okay? The small ones have a diameter of 145 millimeter or 14.5 centimeters, okay? The large ones, like the one you see at the back or here at the front, are 180 millimeter, okay? So that one over there is 180 millimeter diameter. Now these diameters are pretty standard. So if you're going to buy a new element, generally it will be one of those two sizes. Ego, I understand, is one of the largest producers of heating elements for stove tops or cooking tops. So yeah, if you go look around for them, usually you'll find one which fits your cooking top. It was sold back in the day as a no-name, but I happen to remember that it was actually a Zanker, Z-A-N-K-E-R, okay, cooking top. Now, I'm really pleased with it. I don't want to throw it away, so I thought to myself, well, rather than throw it away and buy a new one, I'll just replace the broken element, so this one over here, with this one. Alright, so I lifted the cooktop, or the cooking top, or should I say the stove top, from the working surface, as you can tell, right? So it was just resting in that big gaping hole you see there. Now, the first thing I need to do, well, to be able to work a bit more comfortably on it, is to disconnect it from the power. and you see the mains power connector or connection is over there in the corner, yeah, down there. Alright, I think I disconnected the cooking top from the AC by switching it down in the fuse box, right? But to be sure, let's measure it again. So there you go, 0 volts. Alright, I disconnected temporarily from the AC, right? So I disconnected the cable from the contact block over there. Okay, so I'm debating with myself right now what I should do to open up the stove top or the cooking top to be able to work on the heating element, right? Now I'm uncertain whether I should release these things here, you see, these clamps here, which normally are meant to hold down the whole cooking top to the work surface, or if they also perform a double function, namely keeping the whole bottom bolted down to the top of the cooking top, right? Alright, I moved the stove top to my table in the living room. Well, you know, so that I can sit more comfortably and work on it, and to make sure that nothing drops out of the bottom while I unscrew things, right? So like I said before, there are 4 locking nuts, one for each cooking plate, yeah, and I need to undo these first, and I'm going to first use one of these wrenches to just release them, and then I'm going to use my impact driver to release them all the way. I am going to do that first and then see if that is sufficient to release the bottom. If it isn't, then I will probably have to release the clamps as well, you see here, right? Now these clamps here, like there are 4 clamps in fact, and there are 2 over there, yeah, are really meant to keep the bottom screwed down to the workbench, right? So I don't think they are keeping the whole thing together, as it were, sandwiched together. But that's only a wild guess. Either way, I'm going to start with unlocking the nuts, yeah, and for that I need, let me guess, a 10 mil will probably be too big. No, 10 millimeter wrench will do. So here we go. Okay, that's 1. 2. 3 and 4. Come on, yeah. Okay. So they are released. So now I'm going to use my impact driver to, or my electric screwdriver if you wish, to release them all the way. Okay, I'm going to try to keep them in the correct order. Okay, almost done. Alright, but now, can I lift the whole thing? I would seem I can. Oh yeah, here you go. Alright, so I cleaned up the inside shell of the cooking top. Alright, and here it is, revealed in all its glory. It looks a bit complicated, but I don't think it's really very complicated. Each cooking element needs to be connected to 4 wires, and the wires are color coded. Okay, so so this is the one that needs replacing, and you can tell that the color coding if we go from left to right, is white, purple or blue, let's say, brown or black perhaps, and orange. Okay, so it needs to go in this direction, and it's 4 flathead screws that I need to undo for that. Now, do note this. The elements connection wires or leads are numbered, and if you look closely you'll notice that they are numbered from 1 to 4, but not in that sequence. Okay, so it's not 1 2 3 4, it's 1 2 4 3. It's a small detail, but it's an important one. So there you go. One other thing to notice is that all the elements have one central holding pin, let's call it, and then 2 positioning pins. You see here, these 2 pins here, and then this pin here. And that's exactly what this one has. Yeah, one central holding pin, so this one here, which is threaded, yeah, and then 2 centering pins right here. Okay, like I said, more than likely, I looked it up. I looked up the specifications of this cooking top. All the elements inside of it will probably be of the Ego brand, right? So yeah, the next thing I need to do is to disconnect the whole thing first, and then when I'm done we can open the shell which holds the cooking element down, yeah, clamped down. We'll remove the shell and then we'll install the new element. Alright, I unscrewed the nut which holds the clamshell around the heating element, and it's yet again a 10mm nut. Okay, so technically I should be able to lift this up, and I can. Okay, nothing special, it's just a steel shell, you know, which is clamped around the heating element, and here we are. Here is the heating element itself. I disconnected the wires and I left them more or less in the right order. I made a little note for myself to remember the right color coding, and now I should be able to lift the whole thing up and out. Yes, I think I should be able to do that, but I will need both my hands to do this, because I need to keep the bottom shell in place while I'm lifting up the or lifting out the heating element. Now it's pretty dirty, as you can tell from my hands, so yeah, either you wear gloves or, well, you'll have to clean your hands afterwards. Okay, so let me see if I can manage it like this, you know. Without dropping everything. Yeah, I was afraid of that. Okay, hang on guys. I need both my hands to do this. I'll bring you back once the old heating element is removed, okay? Okay, I used both my hands to reverse the whole thing. And then I used a cleaning pad, or a scotch pad, you know, to clean off the edge of the heating element's position, right? Since now it's easy to reach, it would be foolish of me not to clean it up, right? So yeah, I cleaned up the edges. I checked if everything is okay, nothing is broken or whatever. It all looks okay. So what I can do actually is do a test, sort of a test fit of the new heating element, right? So let's see. Yeah, and it actually fits perfectly. It's the right size. There's a little bit of play, but that's okay. Yeah, it fits perfectly, and this is a 145 diameter, 145 millimeter diameter heating element. Alright, so another advantage of working on a table on this stovetop is that you can slide it to the edge of the table. Alright, you can slide it all the way over to the edge of the table, and then slide, as it were, the element, the heating element, from underneath into the cooking top, right? So let me demonstrate what I did. So you see, I slid it from underneath into the cooking top like this, and then I slid the cooking top back, all the way back up the table like that, and there you go, you know. with a minimum of effort I mounted the new cooking element onto the stove top. So now what I need to do is to mount the clamshell and then reconnect the wires to the 4 leads of the cooking element, of the new cooking element, making sure that I'm not by accident clamping any wires between the clamshell and the top of the stove. Okay, just in case you're curious to know what the resistance values are of the heating element, I'm measuring from pin 1, yeah, to all the other pins in sequence. Okay, so from pin 1 to pin 2 is 430 ohms. From pin 1 to pin 4 is almost 168 ohms. Okay, and from pin 1 to pin 3 is 515 ohms. Okay, remember the pins are numbered 1, 2, 4, 3. Okay, so from 1 to 2, 429 ohms. From 1 to 4, 168 ohms, and from 1 to 3, 515 ohms. Okay, so if we measure the values of the old element now, if I go from pin 1 to pin 2, it's open. Yeah, there's no resistance there. So from 1 to 4, nothing. From 1 to 3, nothing. If I go from 2 to 4, it's almost, well, it's 204 ohms, and from 2 to 3 it's 94 ohms. So yeah, this element, the old element, is definitely broken. So yeah, that's how you know that this element is not good anymore. Okay, so there you go. I mounted the new element in its place. I tightened the clamshell nut as far as I could go, not using humongous amounts of force, just making sure it's connected well to the stove top, right, so that it can't slide. And because of its shape, it positioned itself automatically in the right position at the top, right? So we'll see it once I'll turn the whole thing over. So now I need to reconnect the wires to the element. Annoyingly, the new Ego cooking elements use an Allen wrench type of screw to well, to connect the wires. Okay, I'm saying annoyingly because the old connections could be done with an Allen wrench, as you can tell, but could also be done with a flat screwdriver, right? Because you can see there's a slot milled into the head of the screws. So yeah, it's kind of annoying. I don't know why Ego decided to do it that way. But unfortunately for the new elements, you will need an Allen wrench to mount or to screw the wire contacts. Yeah, unfortunately, a flat screwdriver won't do. So there you go. Now the last one, and we're done. Okay. So yeah, unfortunately, as everything in life, I guess, these cooking elements also wear down, and you know, in the end, they will need to be replaced. I mean, this stovetop I've had for 20 years, I think, maybe even 21 years. So, and this particular cooking element is used on a daily basis, you know. So I'm actually not surprised that it broke down, you know, after all these years of constant use. But I would say 21 years for a cooking element is really, yeah, not too much, you know. Now, I realized suddenly that I might have to do the same thing to another element right next to this one. There's this big one over here, the 180 millimeter or the 18 centimeter one, and that one is also starting to be a bit slow in heating up. So unfortunately I might have to replace it one of these days as well. But yeah, well, you know, first things first, I need to get this cooking element working, and then afterwards we'll see for the others. Alright, I temporarily fixed it by putting some heat shrink around the disconnected wire, you know, and reconnecting the others. Yeah, it's a pity, but it seems like I'll have to buy yet another new heating element. One last to go, and we're done. And there it is, the new heating element mounted to the stove top. And doesn't it look fabulous, right? I mean, this is what it was, and this is what it is now. Looks great, eh? So unfortunately for me, I will have to buy a new 180 millimeter cooking element as well for this side here. Unfortunate, but well, I sort of, you know, felt that probably I might have to do it, but I wasn't sure until I disassembled the whole cooking top, right? So yeah, unfortunately for now, if I can avoid it, I won't use this element. But you know, either way, I'm going to have to order a new one anyway. And to reward ourselves for the work we've done, let's make ourselves a good old-fashioned Italian coffee with a Bialetti, no less. You know, quite a famous coffee maker. And yeah, this is one I usually use in the morning to make myself a cup of coffee. Now you screw on the top. There's water under the filter, right? I don't know if some of you know this kind of filter, but there. Okay. Then you place the filter on top. You fill it with coffee as much as you like. The more coffee, obviously, the stronger the coffee will taste. Then you screw on the top firmly, and I need both my hands to do that. But okay, you get the point. And then, yeah, and then you place it on a heater, either a burner or an electric cooking plate like this. So, shall we try? Shall we see whether it goes boom or it works, right? Well, 3, 2, 1. Well, it didn't go boom. And here comes the fresh coffee. In less than 2 minutes, no less. Bon appetit. The next patient on the slab is my trusted little ultrasonic cleaner, which I've had for a number of years. And it's basically a no-name brand. I mean, if you look at the bottom of it, okay, and I'm going to give you a close-up. Okay, it basically has no name brand. It's called Ultrasonic Cleaner Model 890. Okay, it's meant to be used at my local power rating, so 220 volts, 50 hertz. And apparently they also mention the frequency at which it functions, which is 42 kilohertz, and it consumes roughly 35 watts of power. Now, what happened? Well, a while ago it still functioned perfectly, and basically how it works is that you set at the front a number of seconds you want it to run with this button here, the time button, and I think you can go from as low as 30 seconds all the way up to 900 seconds, which is let me see, which is 15 minutes. Okay, so, and that's what I recently did. I set it on 900 seconds and then I let it run by pushing the on-off button, and it did that, and I let it run for a number of cycles. Okay, so I cycled the cleaning for at least 3 or 4 times right away, so one after another without pause, which I thought was okay. I mean, I did the same thing many times with it, so I thought that was perfectly alright until at a certain moment I went to have a look at it running, and everything was off. The display was off, it was making no sound at all, so it was obviously dead. So I emptied it, and then I had a closer look at the print board, which is this here. Okay, let me give you a little close up, okay, of the print board. So there. So I had a closer look at the print board. Come on, yeah, there. And what I immediately noticed on the print board was this little fuse, which is a solderable fuse. Okay, so it's a fuse, a one-time use fuse you have to solder into a circuit to be able to use it, and it's rated at, if I'm not mistaken, 2 amps. Let me check. Let me see. No, it's rated at 1 amp. It's rated at 1 amp, and it obviously blew. So if I give you a little close-up of it, there. Alright. So you can tell by its coloring. You see how the glass ampule, where the fuse wire is housed, looks completely blackened. Okay, so obviously the fuse blew, and I thought, okay, that's okay. I'll replace it with a removable fuse. So I mounted a fuse holder on the board, okay, and I obviously put in a 1 amp fuse into the fuse holder, and what happened is kind of funny. I plugged it back into the AC, and the display came on, and so far no problems, but when I pressed the button start, it went dead. It went completely dead, which to me at least would seem to suggest that there is a short, a heavy short somewhere on the board, right? So I need to find out where is the short, first of all, and once I've found out where the short is, then I need to find out why it shorted, right? So we obviously would want to try to minimize that type of short. Okay, so where indeed could be the short? And that's a very good question. So we know that as long as I don't switch on the ultrasonic cleaner, as long as the cleaning mechanism. So the ultrasonic inducer, which is this one here, or should I say transducer. So yeah, so this is the electronic transducer right here. Yeah, as long as this isn't running, then we had no problems. It's only when I switch the device on and there is power diverted through relatively thick wires, these wires here. So these, if I'm not mistaken, are 18 gauge. Let me see, does it mention the gauge? Not quite, no. It doesn't mention any gauge or anything, but I would think that the power, the amount of power that runs through these wires is relatively high. Okay, so as soon as I push the start button, the fuse would blow. I'm not going to do it again. I mean, that would be a waste of fuses, right? But trust me, that is what happened. So the display comes on, but when you press the start button, the fuse blows. Now, it's meant to work with this little relay right here. Let me show you. So when you press the start button on the front display, so the center button right here, this button here, yeah, what this does, as far as I can tell, is that it actions this little relay here, yeah, and this relay is rated at 1 amp 6 volts DC, but it also says it can switch up to, let me see, 7 amps 240 volts AC. So this is a rather beefy little relay, right? So you need only 6 volts DC to make it switch, but it can switch up to 7 amps 240 volts AC. Okay, so there's obviously a problem after the relay. So we do know that the relay itself functions okay. So which in turns would tell us that since the display works and the relay works, the power supply in itself works as well. Okay, so the power supply is there. Okay, so this area here is the power supply for everything else on the print board, so which includes the display and of course the ultrasonic cleaner mechanism itself. So you could say the oscillator, as it were. And the oscillator of the ultrasonic cleaner is everything which is located right here. So you can see a perfect divide right here, yeah? So this is a power supply, and this is everything concerning the ultrasonic cleaner, right? So, and the output to the ultrasonic cleaner, so the power output, is this connector here. Okay, so it makes sense that this part here would be the area where the problem is located, right? So basically what I need to do is to check all the parts on the left side, so this side here of the board, and see what could possibly be the source of the problem, right? So that's exactly what I'm going to do. There aren't many active parts actually, so there are a few diodes, and there are two, as far as I can tell, power transistors. So basically, in my opinion, either the transistors are shorted, so these two here are shorted, or possibly this little transformer up here. Alright, I unsoldered the little transformer that was located here, which is connected directly to the output connector here, which goes to the ultrasonic transducer, right? Now it turns out this is not a transformer, so it's that little thing over there, alright? But it is more a choke. Okay, so it's only connected at the two outer pins here. In fact, where you see the little symbol of a coil is drawn, right? So in effect it's not a transformer, it's just a choke coil. Okay, so but I suppose for convenience they mounted it inside a transformer housing. Okay, and I'm measuring the inductance, and it's rated at or it's measured at 1.22 millihenries at 1 kilohertz, as you can tell. Okay, now if I raise the frequency to, let's see, that's 10 kilohertz, and that's 40 kilohertz. If I raise the frequency to 40 kilohertz, which is relatively close to its working frequency, remember it was rated at 43 kilohertz, the inductance drops a little bit, so it becomes 1.2186 millihenries. Okay, so the output choke is still okay. By the way, I did measure the choke with my multimeter, my regular multimeter, and it measures less than 1 ohm. Okay, so it's still conducting okay. So I don't think the trouble that we're looking for is located in that choke over there. So what I need to do now is move on to the power transistors, and the power transistors, both of them, are of a type J13007. Alright, I unsoldered both power transistors from the PCB of the ultrasonic cleaner, and in fact they were located, one was located there, Q5, the other one was located over there, which is marked as Q4. So I hooked one of the transistors up to my little parts tester, so let's see what the result is, right? Oh, that's no good. The transistor measures as a single resistor of half an ohm. Oh, well, yeah, there's your problem. Alright, I hooked up the other transistor to the tester. So now let's check what this will give as a result. Oh, okay. That's not too good. Let's see. Okay, that measures as 2 diodes. Oh dear. That's not good either. I looked around in my stash of parts and I found an equivalent transistor which could replace the 2 broken ones you see over there. Okay, so the old transistors, this one specifically, so this transistor, come on focus, this transistor, the broken one, the J13007-2, is rated at a voltage of emitter collector voltage of 400 volts at a current of about 8 amps. Okay, now the new transistor that I would use to replace it, which is the E13009-2, so this one here, okay, is rated at a emitter collector voltage of 700 volts and at a current of 12 amps. So this one here is a bit beefier than the old transistor, so the broken ones that I'm going to replace. Now these one were specifically described as ideal NPN transistors for switching high current, high electric pulse applications like fluorescent light tubes and stuff like that. So I'm fairly certain that these transistors are very resilient. This is what they actually should measure. Okay. Alright, so I'm going to mount the replacement transistors first to their heatsinks before I mount them back onto the PCB, which makes sense from the point of view that these heatsinks need to rest on top of the PCB, and it's kind of hard to know beforehand how much of the leads I will need to use to make contact with the solder strips or the solder islands on the PCB, right? So if I mount the whole thing like this first and then I mount it back onto the PCB over here, then I don't even need to know exactly how much lead I need. I could just mount it back onto the PCB, solder it, and I'm done, right? So I'm going to use a little bit of heat conductive paste on the back of the transistor before I mount it back on the heatsink over there. Okay, so you don't need to go overboard, just a little bit of heat paste will go a long way, okay? But what I will do is spread it out a little bit on the transistor like this. And by the way, I did clean the transistor's back and the heatsink surface to which it will be mounted with a scratch pad like this, okay, with which you clean out pots and pans. Okay, perfect stuff to do that. And then I just apply the transistor to the heatsink like this. Okay, center it above the hole through which the screw must be applied. So let me look for the screw. Ah, there it is. Okay, so now we screw the whole thing together. And I just need to make sure the transistor stays perfectly centered on the heatsink. Yeah. So while I tighten the screw, I make sure that the transistor is perfectly centered on the heatsink. Okay. So there you go. The transistors, the new ones, are mounted in place. And I applied a little bit of heat paste to both of them before mounting them to the heat sinks. Right? Now, technically speaking, there's one more thing I need to do, and that is to attach the heat sinks to the PCB as they were originally attached. Okay, with a little bit of silicone glue. Okay, so non-conductive glue. But before I do that, we do need to test the circuitry. So I mounted back the choke, and what I need to do now is replace the blown fuse in the fuse holder, reconnect everything to the PCB, so the display and the ultrasonic transducer, and then we can give it a test run. Alright, I reconnected the display and the transducer to the PCB. I didn't glue the heatsinks to the PCB just yet, because I want to try out, obviously, first if the whole thing will work or not. Alright, I filled up the ultrasonic cleaner with some soapy water, and I'm going to clean one of my glasses in the ultrasonic cleaner. So now there is no, technically speaking, on-off switch for the whole device. You just need to plug it in to switch it on, which I'm going to do right now. There you go. It's set to 300 seconds, or in other words 5 minutes. Okay, so what happened before was when I would press the on-off button you see here, yeah, the whole thing would just go dead. Yeah, it was clear that there was some sort of a short or a problem inside of it. But now we replaced the two broken transistors, so those over there, okay, and yeah, well, like I said, the display would work normally, but the real proof of the pudding will be when I tried to switch on the ultrasonic cleaner, right? So here goes nothing. Oh yeah, it works. Well, there you go. I'm not going to let you watch the whole 5 minutes it runs. So I'll bring you back either when it would fail or when it's done. Okay, nearly done. 6, 5, 4, 3, 2, 1, done. Yep. Well, it would seem that the ultrasonic cleaner does work. Which is good news. Good news. So there you go. We're certain that it functions. All I need to do now is obviously is empty it first and dry it off, and then fix the heatsinks permanently to the PCB, and then close it all up, and that will be it.